have a discussion on multi-level programming problem. See, multi-level is a different, and multi-objective has some different features, you can say. So in mathematical programming problems, we have linear, non-linear, linear fractional, quadratic, and all. So now we come to the multi-level programming problems. Multi-objective programming problems means we want to optimize simultaneously each and every objective functions. Now multi-level programming problems is a different. It is a hierarchical programming problems. Then multi-level programming problems concerned with programming problems with multiple decision maker in hierarchical organizations where decisions have interacted with each other. And in multi-level programming problem, each level has objective function which is controlled by a set of decision variables. So this is the example, real-time example of multi-level programming problems. One is the manufacturing unit. We are taking one example of some product. Manufacturing unit, then dealer, then stockist, and finally customer. These are 3 to 4 levels. Manufacturing unit at the top level. दूसरे शब्दों में अपन बात करें, central government, within preview of central government, a state government is run. Within the preview of central and state government, local government is run. घर में एक सबसे बड़ा बुजुर्ग होता है दादाजी, उसके बाद पिताजी होते हैं, उसके बाद आप होते हो, राइट? पहले एक दादी सास होती, उसके बाद सास होती है, उसके बाद बहू होती है. तो उसके प्रीव्यू में सबको अपना अपना डिसीजन देखना पड़ता है. कन्फ्लिक्टिंग तो होता ही है, दैट इज वेरी, लेकिन ये हिरार्किकल स्ट्रक्चर है. तो we are considering one example of some product. One is at top level at manufacturing unit. ठीक है? I think सास बहू का एग्जाम्पल ज्यादा ठीक है.
सर ये हायरार्की बड़ी अच्छी समझ रहे हैं सर. हमारी यूनिवर्सिटी में इसको लेके बहुत झगड़ा रहता है. हाँ,
यूनिवर्सिटीज में या किसी भी ऑर्गेनाइजेशन में
बहुत झगड़ा रहता है. अगर हमारे एक्चुअली कोई चीज अप्रूव ना करे, बीच में कुछ ऐसी बात हो गई थी, मैंने वीसी सर से अप्रूव करा दी, तो जो नीचे के थे डायरेक्टर, सीनियर डायरेक्टर, एचओडी, डीन, वो सब नाराज हो गए सर.
तो आपने उस चैनल को तोड़ के बाईपास कर दिया.
नहीं सर, उन्होंने कहा हायरार्की होती है.
हाँ.
तो मैंने ये कहा सर जी, क्योंकि मैं थोड़ा सा लॉ बैकग्राउंड से हूं, मैंने कहा हायरार्की ऊपर से नीचे भी तो होती है. हाँ. आपके पास अपने आप फाइल आ जाएगी. तो सब लोग नाराज हो गए थे सर. अब मैं हायरार्की फॉलो करता हूं.
मतलब आपने उनको बाईपास करोगे तो नाराज तो होंगे.
कहा था ये काम नहीं होगा, आप जाओ. मैंने वो वीसी सर से अप्रूव करा दिया, तो नाराज हो गए सर.
ये तभी तो मैंने आपको कहा था कि यू आर यंग एंड यू, जो मैं भी ऐसे ही करता था पहले. क्योंकि थोड़ा सा क्या जोश होता है शुरुआत में, जब जस्ट पास होकर के, पास आउट होके 1-2 साल के बाद जब, तो एक अलग एनर्जी होती है. उस समय सोचते हैं कि ये तो सारे बुजुर्ग हैं, ये क्या मुझे, नेचुरली दैट इज इट, नेचुरल. वो सोचते हैं इनको क्या डायरेक्ट करवा देते हैं. बट इसके कुछ साइड इफेक्ट भी होते हैं जो लेटर ऑन समझ नहीं आते हैं.
मुझे आए सर.
हाँ, अभी आपको ज्यादा नहीं आएंगे, थोड़ा और आप करिए तब आएंगे.
मैंने करना ही बंद कर दिया सर एक बार.
बस एक बार में. तो ऐसा नहीं है, देखिए और ट्राई करिए, थोड़ा और लर्निंग एक्सपीरियंस मिलेगा. अभी तो आपकी कन्फ्लिक्ट नहीं हुई है, कन्फ्लिक्ट भी होती है. ये तो आप प्राइवेट स्ट्रक्चर में है तो चलो ठीक है, दे से ऑल आर एट प्राइवेट. गवर्नमेंट में आप करके कर लोगे ना तो यू विल, many troubles will be created because you have to stay with that people always. फुल लाइफ टाइम. तो फिर अगर आपको सास के साथ रहना है बहू बन के, तो मैनेज करना पड़ेगा, नहीं तो दिक्कत हो जाएगी. ठीक है. तो ये एक मल्टी लेवल आप कह सकते हैं, मल्टी लेवल स्ट्रक्चर है. हर एक का अलग ऑब्जेक्टिव फंक्शंस है, हर एक के अलग डिसीजन वेरिएबल्स हैं, बट दे आर इंटररिलेटेड. दैट इज द मेन. मल्टी ऑब्जेक्टिव मीन्स देयर आर different objectives. We need to simultaneously optimize. There is no relation, decision interaction between the objectives, right? And now they have interaction between the objective functions. Even decision variables are also interacting. So that type of problem is called the multi-level programming problem. It is different from multi-objective. It is more complex than multi-objective. So you can see manufacturing unit at top level. Management में भी top level, middle level, bottom level management होता है. So top level have different policies, different objective functions, different strategies, different decision variables, and middle level management has different objectives. But these are connected. Somehow decision variables are connected by each other. Within the preview of that top level, middle management will have to work. And during the preview of top and middle management, lower management need to work, right? So this type of problem, if we formulate that problem in mathematical programming problem, that type of problem is called multi-level programming problems. So we see at manufacturing unit, the objective is maximum sales, because they want their shares part will be increased, maximum sales. Decision variables are investment, running costs, manpower. At dealer level, objective is to maximize profit only. Decision variables are new schemes, discount, transportation cost, right? And at stockist level, objective is maximize profit, but decision variable are running cost, manpower, transportation maybe. And finally, the product reach at the customer. All are interrelated. Decision variables are interrelated. Even the objective functions are also interrelated. So this is called the top level, right? First level, second level, third level. And if you formulate this problem in mathematical format, like this, a tri-level linear programming problem, you can see this is the objective function at first level, objective function are at second level, Z2, and objective function at third level, Z3. X1 and X2 are decision variable at first level, X3 is at second level, and X4 is at third level, right? So X1, X2 will affect first level, but they are connected by this set of constraints. X3 will affect the second level objective, but it is also connected by this set of constraints. If we increase the X3 value, it has to be in this feasible region, right? And third level is like this. So X1, X2, X3 and X4 are connected by this set of constraints, but they are decision variable X1, X2 for the first level, X3, X4 are for second and third level. This is the mathematical form of tri-level linear programming problem. Right? Clear? Now, what is the difference between the multi-level and multi-objective? Multi-objective programming problems means we want to optimize the more than one objective functions, but the decision variables are not interacted with the objective functions. Here the objective functions are in hierarchy, and they are interacted by decision variables, and the decisions come from the top level to bottom level, not from the bottom level to top level. That is necessary. That is the characteristic of multi-level programming. The top level management, top level decision maker will give the options. Out of that options, the second level will choose, and out of that, third level will choose. That is the hierarchy. Hmm? Central government will start, just like today, central government has stopped the currency of 510,000. Every state government has to follow. Now what state government will do? For example, GST. So they have curtailed some of the state government tax. They have to obey the central government rules. But within that preview, the state government what can do? They will introduce some new taxes within that preview only. And local government, just like Nagar Palika or your municipality, what they will do within the preview of central and state government, they will decide some of chungi and all taxes. They can do, but they have to follow all the constraints within that preview. So more and more levels will be increased, the feasible region will curtail. या सेट जो आप रीजन बनाते हैं वो कम होता जाएगा. फर्स्ट लेवल के लिए आपका फिजिबल रीजन था, उसके बाद सेकंड लेवल में और कम हो गया, थर्ड लेवल. तो in that preview we need to search the optimal solutions, but somehow we and rarely we find the optimal solution which satisfy which optimize each and every objective function, but in general we find the compromise optimal solution or satisfactory solutions. We cannot say because optimality is not possible. Not possible, we can't say, rarely possible. So this is the general format. We have T-level maximization type. We have considered T levels. First level, second level, third level in matrix format. Here x1 bar is the set of decision variable at first level. X2 bar is the set of decision variable at the second level, and xt bar is the set of decision variable at. Your set of decision variable may be more than one. It is not necessary always one, x1, x2 or x3, right? And C11 is the coefficient cost vectors, and x1 bar is a decision variable. Now you can see this is the decision variable at first level, but objective function also involve x2 bar and xt bar plus alpha. Alpha is a constant we added, but it will not affect on the solution because these are the constants. X2 bar is a decision variable at second level, and objective function at this level also include the x1 bar, x2 bar and xt bar. So we have considered in matrix format T-level maximization type, multi-level, subject to constraint. Constant may be m constants are there in matrix form. Then x1 bar is equal to x1, x11, x12, x1n1, n1 number of decision variables under the control of first level decision maker. At the first level we have decision variable x1 bar, so it has n1 number of decision variables at first level, and xt bar is nt decision variables under the control of t level decision, the last level, that is t level. It has decision vector xt bar which has nt number of decision variables. Here one decision maker is located on each level. Decision variable xt bar where t is equal to 1 to t is the control of tth level decision maker having nt number of decision variables. For example, if we take x2 bar, it means it includes n2 number of decision variables. So in general, decision variable xt bar is the control of tth level which has nt number of decision variables. This is mathematical format of multi-level programming problems. Now we come a simple problem, that is bi-level. Just like in general, because multi-level is sometimes very complicated or complex. If we consider two level structure like leaders level and followers level, second level. So The bi-level programming problem is a special case of multi-level programming problem with two-level structure. Then leaders level and followers level. So mathematically, a linear bi-level programming problem like this. You can see at the first level, capital X is the decision variable. But at the first level, we have objective function C1x plus D1y. At second level, decision variable is y, and the objective function include C2x plus D2y. This is bi-level, two-level structure. For example, in your organization or your department, you have only your head and you. Then it will become a two-level, bi-level structure. हेड भी आपके ऑब्जेक्टिव फंक्शन में है और आप भी उसके ऑब्जेक्टिव फंक्शन में है और दोनों के डिसीजन वेरिएबल भी इंटर रिलेटेड है. बट आपके साथ ये कंडीशन है कि विद इन द प्रीव्यू ऑफ हेड यू हैव टू वर्क. सो यू विल फाइंड सम सैटिस्फैक्टरी सॉल्यूशन so that no conflicting situation will be there. ठीक है? So this problem can be converted into this mathematical part. Don't take it otherwise because I have given just example. और example जो है ऐसा भी हो सकता है सास है और बहू है तो दो लेवल ही है. Then दोनों के ऑब्जेक्टिव तो सेम ही रहते हैं कि चलो भाई घर का काम करना है या घर में ही रहना है. देन बट कन्फ्लिक्टिंग सिचुएशन तो रहती है तो उसमें आप ऑप्टिमलिटी की बात करना या ऑप्टिमल सॉल्यूशन फाइंड आउट करना इट इज रेयरली हैपेंस बट समहाउ यू कैन फाइंड द सैटिस्फैक्टरी सॉल्यूशन. नहीं ठीक नहीं. उन कंडीशंस में जो बेस्ट सॉल्यूशन आप कर सकते हैं वो. अदरवाइज 0-0 तो सोल्यूशन होगा ही है ना. बट आवर ऑब्जेक्टिव इज टू मैक्सिमाइज द ऑब्जेक्टिव फंक्शन. कुछ नहीं करोगे वो तो सोल्यूशन है ही बट कुछ करना भी है और उस डोमेन में भी रहना है ताकि अपना ऑब्जेक्टिव भी जो है पूरा हो जाए. नौकरी तो करनी है ना आपको. फिर नौकरी छोड़ दोगे तो 0-0 सोल्यूशन तो है ही. So this is the example, don't take it personally. So I have given only to know what is the meaning of this bi-level program. So this is the mathematical structure. Now common features. So any questions from the participant at different nodal centers? Any questions? Any question, Dr. Deepak from CET College, Bikaner?
No sir, no sir.
Okay. Then RC Khetan Polytechnic College, Manav Rachna University, Dr. Vijay Kumar. Yes. Any question, sir?
Hello.
Yes. Any question?
Yes, sir. Multi-level programming and dynamic programming. The problems we can discuss in the same manner. Dynamic programming is stepwise programming, and here we are discussing multi-level programming. Means all the time we are discussing the level stepwise.
See, multi-level has a different characteristics. In your dynamic programming, there are levels, but decision variables are not interrelated.
Okay.
And in multi-level, you can see here decision variables are also interrelated. That is the main difference we can identify. Even more than these differences are there. But the main difference between we can observe that in multi-level decision variables are interrelated and decisions are from top level to bottom level.
Yeah, but as per formulation, if we are thinking in about a problem and we are formulating that problem, the same problem we can formulate in dynamic programming or in multi-level programming. Can we do it?
See, I am not agree with this because dynamic programming has a different part because it does not include the interrelation of decision variables, right? Okay. Only within that preview, see in this case, this is the constant, set of constant, and decision variable X is for first level. And for second level, decision variables are Y. In dynamic programming, we have multiple levels, but decision variables are not interrelated. In my opinion, that is the difference. And you cannot club the dynamic programming problem with multi-level programming problem. They have significant difference between them.
Yeah, that I can understand, sir. But this we are thinking we are solving the problem through dynamic programming. Then we can create two questions, two formulation for different problems, and then we can solve it. Then it can be possible.
See, in next slide, I will let you know what are the common features of multi-level. Then you will realize that what is the difference between the dynamic and multi-level. So after that slide, then you can ask me. I think by that slide, it will be clear.
Okay.
So this is the common features of multi-level programming problems. You can see the interactive decision-making unit exists within the hierarchical structure.
Sir, can you discuss some live problems of this?
Yeah, in later slides we will discuss the real problems, and we have already discussed this problem. You can see this is a multi-level programming problem where there are three levels: manufacturing, dealers, stockist. So this is the real world example of multi-level programming problem.
No,
For
sir,
example-
that is fine. We understand the thing that you explained now. But if you explain this thing by taking some numerical example, then it will very easy for us to grasp the topic.
See, again, I have given this numerical example. You can see we have three levels: first level, second level, and third level. At first level, we have decision variable x1, x2. It means x1, x2 is affecting the first level decision. And
Sir, solution, sir, if you explain the solution of it, then it is very easy for us to understand.
see, we are talking about this problem. There are many techniques have been developed by researchers. More and more work are going on that particular problem. So
Okay.
many different techniques are there now. Even more and more new techniques are being applied to find some satisfactory solution of that problems. But in this session, we will only discuss what is the problem, what is the characteristic of that problem, because solution technique is a broad area. So it involves many techniques. So in this session, I will only introduce you about the multi-level and its important characteristics.
Okay, can you share any references whom we refer and we get something out of it regarding this topic?
See, there are, in my opinion, limited books are available, and if you type Google this, you will have some books, but some limited PDF version is available. But research papers are in bulk quantity is available on Google. If you search on Scopus database, you will have so many research papers related to the multi-level and bi-level programming problem. So that is the only source of collecting literature on this problem, because right now there are limited number of books.
Can you have any book in your reservoir that you can share with us?
See, even I am now in process of publishing books, but it will take time, 6 months. Then I will send you one copy of that book, which is
E-book. If you have any e-book of this,
e-books is presently, in my knowledge, e-book is not available on this topic. Only limited books are available, which are in the libraries of IITs.
okay.
Or which are copyrighted by elsewhere. So it will not be open access. So it is difficult to download this. But if you are working in some IITs, then there you can download that books.
Okay, thank you, sir.
So interacting decision-making unit exists within a hierarchical structure. The execution of decision is sequential from higher level to lower level. That is important. You cannot impose decision from lower level to higher level, because if you impose the decision from lower level, that decision may not be suitable to the upper level. But as a hierarchical nature, it is customary to use the decisions from higher level to lower level. That question is also important. In some research paper I have seen that many authors also assume that the decisions are from lower level to, then they derive some of the properties. That is also a new area of research on this, but it is very limited. As a customary, we assume that the execution of decision is from higher level to lower level, right? Each decision-making unit independently control a set of variables and is interested in maximizing its own objective. At each level, you can see there are set of decision variables, and they are interested in their own maximizing their own objective, but is affected by the reaction of lower level. Due to this and due to their dissatisfaction with the decision of higher level, because every level they want their objective functions and objective functions are somehow contradictory. So there is some dissatisfaction with the decision of higher level is there. Even the decision deadlock situation arises. Sometimes it becomes a very complex structure because of the interactive behavior. Decision deadlock situation there. कोई डिसीजन ही नहीं पता है, राइट? आपने कह दिया ये होना चाहिए, आपके बॉस ने कह दिया ये होना चाहिए, और डायरेक्टर ने कह दिया कुछ और होना चाहिए. तो वो तो फिर हायर लेवल से होना चाहिए ना. दैट इज व्हाई हायर लेवल से आप स्टार्ट करो. आप अपना डिसीजन रखो ही मत, उनके डिसीजन से चलो, है ना. सो इट्स सबऑर्डिनेट लेवल means lower level execute its policies after and view of the decision of superior level. That is why it has been formulated as a multi-level, right? Unless until you assume some of the condition at your own, is that decision should be from lower level to higher level. That may be a different exceptional case, but this subordinate level execute its policies after and view of decision of superior. Now each unit try to maximize the net benefit independently of other units, but may be affected by the action and reaction of those units. Decision deadlock frequently arise in decision making situation. In this type of problems, it is very sometimes decision deadlock situation arises because it is a hierarchical. It is very difficult to find a satisfactory solution for each and every level. So decision deadlock situations arises in this type of problems. Again, we have extension. So any questions from participant at different nodal centers? Now these are the extension of multi-level programming problems. Again, we have extended this. Multi-level linear fractional programming means at each level we have objective function in the form of fractional. Again, it becomes very complicated. And multi-level, multi-objective. At every level we have more than one objective function. It creates more problem. So now that is the optimization. Now you find which solution is optimum to you. Taking a LPP, it is okay. You can find. But what will be the optimal solution for much complex problem like that? That is multi-level, multi-objective. Even multi-objective, it is very difficult to find the satisfactory solutions. And what will happen for the multi-level? Even many papers have been already published on that area. Multi-level, multi-objectives. They are given the different techniques based on fuzzy, artificial neural particles. So many work have already been done on this particular problems. Even bi-level has been completely done, and I think from last 10 years, papers on bi-level is not being accepted by the editors. Even now, multi-level objective. Many papers have already. So these fields are old now. In my point of view, these are because many works have already been done. Many algorithms, many techniques have been applied to find some satisfactory solution. Now people are using hybrids of techniques. They are using more than one techniques. They are giving some analysis, comparative analysis with one technique, so that their paper may get published in some of the journals. So multi-level, multi-objective linear fractional programming. Again, there are multiple objectives, but each and every objective function have fractional format. This is the multi-level linear fractional programming. You can see there are T levels. At each level, objective function is of linear fractional format. And all the levels are interactive. So we cannot apply the techniques of multi-objective programming problem to the multi-level structure, because multi-level structure has a important features of interactive behavior, interactive decision making units. राइट आप इसका एक जनरल बात करें, आप 3 पार्टिसिपेंट हो 4, उन सबका ऑब्जेक्टिव फंक्शन मैक्सिमाइज करना, दैट इज मल्टी ऑब्जेक्टिव. और अगर आपका बॉस बैठा हो और उसके आगे आप जो है उनका बॉस बैठा हो, नाउ एंड दे हैव डिफरेंट ऑब्जेक्टिव्स एंड 3 आर कनेक्टेड, नाउ दिस प्रॉब्लम इज मल्टी लेवल. If you have no interaction between them, then that type of problem may be considered as a multi-objective. But if there are some interaction in terms of decision variable, then it is multi-level. सास और बहू बाहर जो है देखने में बिल्कुल समान लगेगी, लेकिन घर के अंदर तो सास रहेगी, राइट? तो ये एक जनरल एग्जांपल है. एनीवे, so this is multi-level linear fractional programming. और ये एग्जांपल भी मुझे जो है मेरे गाइड ने बताया था समझाने के लिए, तो फिर मुझे समझ में आ गई थी बात कि एग्जैक्टली है क्या. हाँ, मैंने पीएचडी इसमें स्टार्ट की थी, लेकिन स्लाइटली डाइवर्ट होते होते फिर अब दूसरे फील्ड में चले गए. So it is a learning process, because once you start with the subject, automatically when you are in research, new techniques will be there. आप जितना ज्यादा लिटरेचर, तो फिर सोचते हैं कि ये भी है, इसमें और यूज कर सकते हैं. तो I started in this, then I used fuzzy, then PSO, neural, then I am now coming to taboo search method. So these are some methods जिसको आप यूज करते रहते हैं लोग. बट लेकिन ये एग्जाम्पल अच्छा है. आपके बॉस का और एक इंस्टीट्यूशन का एग्जाम्पल भी हो सकता है. सो दिस इज योर मल्टी लेवल लीनियर फ्रैक्शनल प्रोग्रामिंग, द सेम स्ट्रक्चर. दिस इज मल्टी लेवल मल्टी ऑब्जेक्ट. नाउ इट बिकम्स मोर कॉम्प्लेक्स. यू कैन ओनली सर्च सम सॉल्यूशंस. Okay. So at first level you can see there are one m number of objectives, and second level we have 2m number of objectives, and all our decision variables are interacted. It is hierarchical level. So this becomes the multi-level multi-objective linear programming. Here we use the term linear because the objective function and constant are in linear format, because we restrict. Even more and more extension problems are there, but it is very difficult to find the satisfactory solution. So they try some search methods.
We cannot get the unique solution that is.
Rarely we can get.
Because if we have determined we can do some implementation of the problem, and we can get some more improved result.
Yes. So because it is
Drawback of the thing.
yes.
Another person can do some more good results from this given condition.
Yes.
Using some improved condition.
Yes. So that is why a robust method is not available to find the robust means a method, just like a fixed method is not available, so that we find some. So the people are working on that. They're using different techniques.
Discuss the robust optimization.
Huh?
Robust optimization.
No, robust optimization is different.
We will discuss here.
No, we will not discuss robust optimization. That is a different area. So any questions from participant? Any questions from the participant at Nodal Center? Any questions from Manav Rachna University? Dr. Vijay, any question?
No questions, sir.
Okay. So these are the mathematical. This is again multi-level, multi-objective linear fractional programming. We have extended this multi-level, multi-objective, non-linear. So in this type of multi-level, multi-objective programming problems concerned with programming problems with multiple decision makers and multiple objective function at each level, where each objective function is in the ratio of two linear functions or in fractional format. So mathematically this problem can be stated as in this format. We have T-level structure, we have multiple objective at each level, and each objective function are also in fractional form. So now you can imagine what type of theory you will adopt. Either you adopt the theory of fractional programming or you will adopt the theory of multi-level. And so it becomes difficult to find the satisfactory solution. So the people use different techniques. Like taboo search. Taboo search is just a searching method. So they use the MATLAB code, they find out the results. So any questions from the participant at nodal centers? Government College Bikaner and RC Khetan. Only one center is connected. Okay. So this is the mathematical format of multi-level, multi-objective linear fractional programming, and other have same notations. Here we also assume that the denominator of each objective is positive on your constant region. This is the assumption we assume for the fractional part in order to define problem. If this assumption is not there, maybe at some point the denominator becomes infinity. So you will not get a satisfactory solution there.